Welcome to lesson 9-8. Today we're going to talk about making polyhedra and other surfaces. A polyhedron is a three-dimensional surface or a 3D object that is a combination of polygons, the faces, and has no holes. So the faces of the polyhedron shown here would be this area in here. This is its face. While the edges, the intersection of two faces, is there's an edge here, one here, one here, one here, one here, and then the one in the back. Finally, the vertices are the endpoints of the edges. So that would be here, 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 and here. So it's where all the edges come together into one point. A polyhedron with 4 faces is called a tetrahedron. And a polyhedron with 6 faces is called a hexahedron. A regular polyhedron is where all the faces are congruent, regular polygons, and the same number of edges intersects at each of the vertices. So, if we look at the triangle pyramid, it's a regular polygon because at this vertex it has 3 edges. Here it has 3 edges coming to it, there, and then each triangle is a regular polygon, congruent regular polygon. A net is a 2-dimensional figure that is created when you unfold your 3-dimensional surface. So as shown here below, you have a 3-dimensional surface that has been taken apart or unfolded to create a net. For this example, we're going to draw the net of the 3D surface to the right here. So to start with, I'm actually going to draw the bottom view of the 3D surface. So I know it's a rectangle. I'm going to add my scale to it, so I know that this is going to be 3 centimeters across and 3 centimeters up. If you want to think about it, it's over here. We know that it's 1 centimeter and 2 centimeters, and then we know that this is 1 centimeter and this is 2 centimeters. So we know that the measure of the bottom, or the view of the bottom, is 3 centimeters by 8 centimeters. So next I'm going to go to the front, this lower front rectangle here, and draw that. So I know that that's bad. So we have a rectangle here, and we know that its height is 1 centimeter. Next we draw this top face, which is the rectangle, which is a rectangle. That is 2 centimeters. The next one I'm going to draw is this face right here, which is another 2 by 8 rectangle. So we'll draw it. We have a 2 centimeters. So we have constructed the bottom, this front panel, this top one, another front one, and now we have to do this top rectangle here, which is going to be 1 centimeter. It's 1 centimeter. And then we have our back side of our 3-dimensional surface, which is 3 centimeters. Actually, won't label this side just yet. So now that we have drawn all of those, we also have to draw this L shape here. To do that, I'm going to draw it off the back because I know it's connected to the back face, or the face of the back is connected to the face on the left side. And it looks to me like it would be a backwards L, so I'm going to draw that. And then there's also one on the right, so I'm going to draw that. And then label my distances. So we know it's 3 centimeters, 8 centimeters, 3 centimeters. This distance up is 1 centimeter. This distance here, here's our 1 centimeter, it's going to be 2 centimeters. Actually, we're going to label this on the other side. This distance here is 2 centimeters. Got to reference my photo. And then 1 centimeter. So we have just created the net of the 3D surface to the right here. What I would like you to do now is to stop the video and think of another way you could draw this net. Now that we've drawn the net and you have practiced drawing the net, we're going to find the area of the faces. So what I notice in this picture is I have an 8 by something rectangle right here, really big rectangle. So I know area of a rectangle equals base times height. So the area of this rectangle that I've outlined in blue is going to be 8 times 12, I believe. Check my math, because 3 plus 1, 4, 6, 8, 9, 12. 8 times 12 equals 96 centimeters. So that just means I found the area of this blue rectangle. So I'm going to have to add on the area of these 2 red L's. So if I want to, I could break this up into more rectangles just so I can find the area. So since there's 2 of them, I only have to find the area of 1. So we're going to go 2 times the area of this square here, which is 2 centimeters by 2 centimeters. 2 centimeters by 1 centimeter, so 2 times 1 is 2, plus the area of this long rectangle here, which is 3 centimeters by 1 centimeter, so times 3, or plus 3. So the area of our red L's would be 10 centimeters, making our total area, so making our area of the net equal the blue rectangle, which is 96 centimeters, plus the red rectangles, which equals 10 centimeters, equaling a total of 106 centimeters.